Welcome back to your first GameMaker Studio shader, and this one again is the Desaturation shader. There will be no intro, so I will just go right into the code. But first of all, you need to understand how shaders work and how they're being created and what those variables mean, because for now you've been a little bit spoiled in quotation marks, and actually like that you have like global access and you don't have to declare your data type and so on, which is pretty sweet. But for now, for example, you go, and I will just tell you that you go into shaders, and for example, if you create a new one, create shader, and bam, you're greeted with two shaders. The first one with lots of stuff in there is the vertex shader. So this is one of the first ones. For example, if you have seen my last video here, bam, this guy here, and he's just taking the vertices, and you can basically just kill it. And what you just need to know, two variables which are VV_TextCord and VV_TextColor, because of the varying keyword passed to the pixel shader, which is the fragment shader, of course, but I just call it the pixel shader because it's easier to memorize. That thing looks much easier. That's why we just do it. And here will be most of the action. So this one you can completely forget. Basically, what you just need to know is that you're getting passed in two vectors, which is a vec2 and a vec4. And yes, they are vectors. So we are not in the realm of strings and numbers and so on. Now we're having vectors, and there are a few different things you need to know and apply that. So a few changes. So these two guys are just gonna get passed in and they land in your fragment, aka pixel shader. From now on, I will just call it pixel shader. So what are those two vectors? Well, let's start, for example, with the VV color, which is the easier one. For example, if you're having something like this, and here, for example, you have one big texture, you have your vertices lined together, for example, for this triangle, and you want to have that point, and you can just pinpoint it by, let's say, 3 vertices, and there you can pinpoint it very accurately, or I don't know, 4 if you like. And here, this would be the pixel, for example, here, this one, on that texture. But for example, if you're using, well, your shaders, for example, you say, I want to tint a little bit, just change the color, and this is like a blue tinting in here, a yellowish, and then between those things, you get a yellowish bluish color, and that is the VV color. So this is just a passed in color from your vertex shader inside to your fragment pixel shader. So you go in here, bam, you get the VV color. And this is quite important because you having this one for mixing and this thing, but this is another thing. For example, here, what do we have? GM based texture. This is very easy to understand. This is basically a texture you're working on. This is the sprite. For example, here, without the tinting, for example, you have your vertices and you want to have exactly that pixel in that sprite, in this texture. So basically this sprite, and it should be like, I don't know, some violet pixel, and that you get in on the GM based texture which you are looking for. And then you say the VV text coordinate, and this is the coordinate. For example, if you go back in here, you just say, all right, let's go down here, and this is basically just the coordinate of it. And then it says, okay, let's run this kind of method on our texture with the coordinate, and then we get the pixel. And then the pixel is getting multiplied by the passed in color, and then we get some tinting. For example, here, bam, then we would end up with a specific pixel, because that's what the pixel shader does. It just gives back a pixel. That it is what it is in practice, and that it does quite a lot of times. The calculation is quite huge, so there's been lots of things going on, but the graphics card can handle that with ease. And that's why we have such beautiful games. I don't know, like Destiny 2, for example. I played that. Amazingly good looking and amazingly boring game. I cannot get into it, but this is a different story. So if you guys are having fun with that, more power to you. I tried it. I don't know, it was super boring, but I guess I'm not into those kind of games. Who knows? So once again, let's get back to the shader, our pixel shader. So basically you're getting the text coordinate passed in from, well, the other shader. So this is just on the texture your coordinates, and you're getting in the color, and then you color it, and then because it's a function you need to do something, and you get your color being, well, calculated, and then you get, I don't know, all your colors, I don't know, a yellow color, a violet, orange, red, whatever, and all that stuff. This is what you get out, and this is in principle the whole shader. Not too complicated, just if you see it the first time you may be like, oh, what is this? It's not too complicated once you understand actually what that means. Your texture coordinate, return the pixel, and multiply it with the kind of tinting UV color. And then in the end, set it to the pixel we want to get. This is basically the pixel. So here we can change a few things. So for example, if you go into the desaturation shader, and here I have to clean up a little bit so you don't get stuff we don't need. So let's kill all that stuff here. Bam, bam, and we are good here. So basically what is happening here? First of all, what am I doing? For example, what do we want? What is desaturation? If you go, for example, into Photoshop and pop up the colors, for example, these guys are absolutely desaturated. They are like gray values between white and black. And as you can see, you have a red, a green, and a blue value. And as you can see, the numbers are always, well, the same. So this is how we can desaturate. For example, if you do not desaturate too much, the numbers will be close, but not too close. And that you will use in the desaturation shader here. And that's why we have this little number 3. So what are we doing? Let's jump back into, well, our original empty pass-in shader, because pass-in shader just means it's there, it's not doing anything, and this is sweet. So for example, we have GL frag, so the pixel we want to have, and the whole line. So let's copy that in and do that in here. And as you can see, it looks very similar to the stuff we did here. So basically we're changing nothing, kill that too, but we are storing into a vector 4 because we have vectors now, and I call it just desaturate out the whole stuff. We're not just well, putting the whole output into our pixel we want to have, we just put it into another variable. Why do we do that? Because we need to do some transformations here. So first of all, we want to have the kind of total, well, value, which is here, one of those here. So how do we get that? Basically we just take our vector 4 and take out the parts we want, and that you can take out by RGB. And you're just thinking RGB, red, green, blue, then you're right, because this color vector, which we in the end have, has 4 values, which is red, green, and blue. But for now we have 3. So what is the 4th one? It's alpha. So just keep that in mind. So we're just basically splitting that up, and we want to get our R value, so our red value, our green value, our blue value, and just connect them with a dot. So we get them, we make, well, we add them together and divide them by 3. And because we are now using well, the stuff inside here, we need to, for example, store it into a variable. But because, well, we are now entering evil Java territory, we need to define the data type, and the data type is a number. And the number, for example, which is the 3.0 is a float. So just keep that in mind. This is, for example, int would be something like this, but we need to use a float here. Why is that very important? Because, for example, if you do something like this, it would work in GMS, but here it doesn't. So just keep that in mind. It's very, very data sensitive. So basically everything needs to be in accordance. If it doesn't, it won't run, it will throw an error. And the error, well, finding in GMS is let's call it not very efficient for shaders. It doesn't really tell you what's going on. So yeah, you have to be very, very, very accurate with the stuff you are doing. So basically, what are we doing here? We are storing into a number a total desaturation from the current numbers which we are having, because these are the ones which we are getting. So for now, we haven't changed anything. We just stored a completely desaturated color which we are getting, because here we're just getting lots of numbers, and this is one of them. So lots of colors basically. And here, this is the number for the color stored in the float. And now we want to mix it, because we don't want it to be, well, fully desaturated. We want to desaturate it with well, with a value. So basically we are just doing something, if you've seen my other videos, with a lerp function. A lerp function is just a linear interpolation between, well, on one value, and then you just say, all right, you want to go between two values, between, I don't know, 0 and 1. So basically 0 or 100, depending how much you want. So this is almost the same here. For example, what we are doing, we're creating a vector 3, because we're just having our 3 values. So of course, you could split it up and do it every time for the RGB, but you can chain them like this together, and this is automatically a vector 3. So what do? We just store, we make another variable which we call vector 3, and just keep in mind, you just have to write the variable's name data type once. If you do it twice, for example, it will throw an error as well. You just have to declare it once. Then we go mix, and mix is like a lerp, but just for vectors. And then you take the original RGB value, which are those guys here, together, and you say, okay, I want, what is this value? Well, our completely desaturated value. So this is like fully desaturated, and because you cannot just put in a number and compare it to a vector, you need to do a constructor and just say vec3 in, well, those I don't actually, how do you call that in English? German would be Klammern, I don't know, those things, and you construct a vector out of this number. So basically now we're having 3 times the same number. So I don't know if the number would be, I don't know, 28, then you would be having 28, 28, 28 as a vector 3. And now here, this is the interesting part, here we do a strength. And this strength is a passed in value from the outside, which is defining how much we want to go from the original color to the desaturated color. So just keep that in mind as well. So for example, here are the 2 values we want to compare: completely desaturated and fully normal color. And here we just say how much we want to do that. And then in the end, now we'll come to this point in a few seconds, we do and create our pixel. This is it. We just say, all right, we need to have a vector 4, put in our interpolated, our linear well, pixel, the vector here, which we just created here by defining its strengths between, well, desaturated from our, well, normal pixel. And then we forgot something, our alpha value, because this is just the vec3, but we need to put in our alpha, and the alpha is the one from the start, which we took out here. Then we put that together in a nice package, which is a constructor again. So it's nice and easy, because now we need to have, like, in the end, a vector for the left side and a vector for the right side, and bam, it does work. So basically this is the stuff how it works. And for example, once we start that thing again, it works because, well, I didn't change anything, and this is the shader by itself. And as you can see, it desaturates the color but doesn't change the alpha, so the transparency value, and it looks pretty nice. So how do we change it actually? So first of all, the strength I change with a little helper. I just call it tester here. This is an object which does not a lot of things, it just has one value. I'd call it to change value, and for example, if I press on my keyboard down, the value is getting smaller, and I press up, the value is getting bigger, and it will be, because I just use this one, between 0 and almost 0 and 1. And this is it. These are the values you want to change, because, well, it can be fully desaturated by 1 and almost nothing, or basically nothing, but 0.01. So this is the tester, and let's get into our object, because you need to put it somewhere. You use your shader in an object. For example, what you can do, for example here, let's kill this guy here for now. How do shaders work? Basically, you just go on your draw or draw GUI, depending what you want to, well, use your shader on. For example here, you just go set shader, and then give it the name of the shader, which is this guy here, and then you have to reset it. And here inside happens the action, what you actually want to draw differently. For example here, what I did is draw a slime, and draw a slime again, but just with a little, well, 150 pixels to the right, so you can see. For example, once we started, you see that the shader is getting started. It draws the first slime and the second slime, and now I desaturate, and bam, you see the left one is being affected by the shader and the right one not. And for example, if you want to do that on the whole screen, basically on everything, you just say, alright, let's do that on our application service. And once we run it again, well, we do our desaturation shader, and bam, everything is getting desaturated. So these are two nice ways how you can change, well, to do that on single things or on everything. And of course there are ways how you can do that on specific layers, but I'm not gonna show you that today. And here we come to the part, but how do we actually enter the desaturation shader? For example here, how is that possible? Is it like a GMS? And no, GameMaker is very flexible concerning how you can, well, enter different objects. For example, if you have one object, if you want to enter the other object, you just go, I don't know, let's say, how is this object called? I don't know, blah, 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 blah. And you press a dot, and then you, for example, you can access its variables if it has any. No, doesn't matter. So for example here, you could just enter the object and then the variable, and you can change that variable. In the shaders, it's not possible. You cannot have those, because they are global values. You cannot have those global variables, because this is how GMS handles all the objects. All objects can, well, access all the other objects variables, but here this is impossible. So you have to do something like uniforms, and uniforms you have to declare once with their data type, which is a float, because here we need a float. This is a number between 0 and 1. So once again, so for this lerp function, you need to have like how much you want the strength, and you declare it. And once you declare it, then you're pretty much fine and dandy, but you cannot access it. This is a little bit complicated. I know it's kind of, well, abstracted, but well, this is how you can do it. Basically, what you need to do is getting uniforms and setting uniforms, and that you do by the command get uniform, and then you just store it into a variable. I just call it Desaturate. You send it to the shader, and then you say how this variable which you want to control is called, and you just put it in like a string in quotation marks, and that is the thing you saw in the desaturation shader. Let's kill that guy here. That's this guy. So even though you declared it once here, you have to pass it kind of into the shader. So let's get back in here. So first of all, the shader is getting your variable which you want to control, but for now it's doing nothing. And then what you do is just say alright, on the shader you set it, and this is shader set uniform F. F stands for float. This is the data type which you are passing in, and then as you maybe remember, this is the one we created, Desaturate. This is this guy here, and then we say okay, what kind of value we want to put in, and this is the value between 0 and 1, and this I put into my tester dot change to value. And this is how you make the jump from your objects from GameMaker Studio into your shader. This is how it happens. So basically, once again, do the get for the shader, so he gets this variable, then you set it and change it in the runtime. And then if you enter the shader, you need to declare it once. As you can see, uniform, then the data type, how the thing is called, and then you're ready and can use it inside here. This is how it works. This is the whole principle. I know it's a little bit confusing at start, and I haven't explained a lot of things. For example, I don't know how actually those constructors work and all that stuff, but I wanted to give you a rough instruction how to get in, how you can actually use your first shader, and this is how you can do it. And that stuff is gonna get very similar in the coming videos. First of all, you will do an output, then you will have passed in variables which are just going in here, so you can change and test stuff. In here there will be some operations, some changing of the RGB and alpha. So this is where most of the stuff is happening, because once again we are just having RGB and alpha, and this is how we create those pixels. This is what the pixel shader is actually doing. In principle, it's not too difficult, but you just have to wrap your head around how you can actually get the results which you need to make those coloring happen. And then of course there will be more stuff happening in here. This is one of the easiest ones, because some of the shaders, well, they're getting quite complicated in the end. So just stay tuned for more. Hopefully that was not too difficult for you guys, and see you the next time. Have a good one up indie.